So, I don't want to do a lot today because, I don't know, some of you guys need to go lick your wounds, but we'll do a little bit. We'll get back into this. Next class, I want to have this kind of like free-for-all. We put you in groups. We're going to solve a lot of equations. That just sounds awesome. That's what you want to do in the morning. And then we're going to actually get into what I warned you about before and what you knew had to come someday. Word problems. Right? It's coming. And I hate how much hatred there is of word problems because on one level I understand. You always have these dumbass word problems in algebra class. I totally get that. You got this guy that forgot how much money he put in the bank. Who the hell is this guy? Who is this person?
How much money did you put in the bank? Was it $10,000 or $15,000? I don't know. Thousands of dollars coming out of my pocket, put it in the...
Who is this person? I can help you with that problem if you have too much money, remember? Or you got these weird problems that are like, but it's unfortunate we just don't know enough math to do like a real life problem because the math that describes real life probably is pretty messy because real life is messy.
Oh, wait.
Did you get a copy of them?
Yeah, I think I had one. I remember doing it, I just can't remember when.
Kabam, you got it. Alright. So, let's see. Let's do a problem together. Let's start off really, really, really nice. Just make sure everybody's on the same page. Good. Well, with this problem, there's a really simple mistake people make. How do you solve this? I like it. What would you tell the person that does this? Do you see what they're looking at?
The negative.
Say again?
The negative.
They're looking at the negative. So what would you tell them to try to explain to them why what they're doing is wrong?
The 2 is not adding to the x, it's multiplying.
Multiplying, good. So you always focus on what the operation is. Say gas. George's like, I can take over this class. You look at the operation that's happening, right? So why is the x not by itself? That dumb negative 2 is currently multiplying, so I'm going to do what's going to kill it, which is divide. You always want to undo the operation. So you divide by the thing you don't want. Whatever you do to one side, you do to the other side to maintain the balance. Right? I always think about, have you guys all seen Indiana Jones? The first one, like the good one, not the most recent one. Where he takes that little idol off and he puts he's trying to keep the balance, right? He takes it away, put it back on. So here, I got to do it to both sides to keep the balance correct. So here, of course, those cancel, and I get negative 8. Cool. And then if I want to check it, I would do negative 2 times negative 8, and that does equal 16 like it's supposed to. Check. Just plug that in and see if it works. I like it. So what this means, when I get an answer, what it really means is, when this is true, let me rewrite the original. When this is true, then this is true. That's what that means. When this statement is true, then this statement is true. So, how would you do this one? This one you would add 2 because the operation is subtract. So we're going to add 2. X is 18. 18 minus 2 is 16. Check. Alright. Okay, cool. Just make sure everybody's with me on the basics. Alright. Now let's take a semi-big step. Sure. Why not? Yes, ma'am.
Subtract 7x, bring it up to the 4x, 4 minus 7, negative 3x, and then add the 11 over, so 11 plus 4 is 15, then...
I got you. Let's catch up. So, when you have the ones I've done so far, before this one were easy because all the x's were already just on one side. So now we're starting to see a more general idea. I want to get all my x's on one side and all my numbers on the other so then I can just divide to get the answer. I almost always divide last. Right? So if I get all my x's together, so you could subtract 7x total. And that's nothing wrong with that. Nothing wrong with that. But what I normally do is I try to keep it positive so I don't make a negative mistake. So instead of subtracting 7x, I could do what? Subtract 4x over. But nothing wrong. Please, Morgan, understand. What she said was beautiful, was perfect. But just a little suggestion, just negative mistakes happen to everybody, including me, so I don't let them even come up if I can control it. So subtract 4x. So I get negative 11 equals 3x plus 4. And now all my x's are together, but my numbers are on different sides, so I need to do what? Subtract 4. And then you almost always divide last. Divide by 3, divide by 3. X equals negative. I lock it. So when I check it, if I were to check this, plug negative 5 back in, 4 times negative 5 minus 11 equals 7 times negative 5 plus 4. Is that true? 4 times negative 5 is negative 20 minus 11, negative 31. 7 times negative 5 is negative 35 plus 4 is negative 30. Check. Yay! So if this does not work, that doesn't mean there's no solution. It means that the answer you thought it was is wrong. So this check is meant, if this doesn't work, you got to go back and try this again. I would double check and make sure I did this right before I go and do this whole thing again. It sucks when your check's work is wrong and your answer is actually right. That would so desperately suck. Okay, so some of you guys, I love the look on your faces.
What are you doing? This is easy.
But again, there's a lot of different people with a lot of different backgrounds in this room right now, so I'm going to make sure that we're all on the same page. Does everybody feel decently comfortable so far? Tell me honestly. Okay, cool. So let's crank it up. So you guys try this one on your own. Let's see what happens. The answer could come out to be a fraction, but hold on. Of course, which one do I let you do on your own? The hardest one, yes. Doing it on my head, I got 3/4 out. See what it is. What's the very first thing you need to do?
Distribute.
Distribute. I love it. So that you free everything up so they're able to be like terms put together. Right now, all this stuff is stuck inside there. Just let the 4 get in there and break the walls down. So what do I get? 8x
Minus 20.
minus 20.
Actually, that's 7. 3x.
3x.
Minus 10. Plus
Good. Minus 10. And the biggest mistake, it should be plus 2x, because it's negative 2 times negative x, positive 2x. Oh, is that the mistake? No, not fine. We'll see. 1 is it 1? Well, we'll see. So then we get 8x, what do you get here? Minus 13 equals 5x minus 10. And do you see how it looks exactly like this problem now? Combination of x's and numbers, combination of x's and numbers. So you pick which side to move the x's and move the numbers to the other side. It was a very kind of flowing way to do this. So how do you want to move the x's? What do you want to... Yeah, subtract 5x to keep it all positive. Well, it came out to be 1. That's nice. Oh, also nice. I wish I could take credit for that, but no, I can't. So we get 3x minus 13 equals negative 10. Add 13. 3x equals 3. So x equals 1. I like it. Cool. So if this is true, then this whole statement is true. Now real quick, just to show you a real life use of solving equations that isn't horrible to look at. I used to live in North Park, and there was a gym down the road, and I can't remember exactly what it was, but you could pay $200 plus $30 a month. You guys see how that equation gets put together? The number of months, I don't know the number of months, so I'm going to make it X. So $200 up front plus $30 a month. Or I could pay $300 up front plus $20 a month. So then I can ask, well, shit, if I think I'm going to live there for a year, which way would be the better way to go? Do you guys see the question? So what I can do is I can see, well, when are these plans equal to each other? Do you see why they would eventually equal each other? Here I got to pay less up front, but I'm paying more each month. So eventually that way is going to catch up to this way, and then it's going to be worse after a certain point. So one way is better if I'm going to live there a long time, and the other way is better if I'm going to live there a short time. So if I set them equal to each other, I can see where's that middle point. And now I know how to solve this equation, right? So what do I do to solve this equation? Yeah, subtract 20x. So you get 200 plus 10x equals 300. Subtract 200. So you get 10x equals 100. So after 10 months, they're the same. So if I'm going to live there longer than 10 months, I want to use the plan that charges me less per month. If I'm going to live there less than 10 months, I want to use a plan that charges me more per month, less up front. You guys kind of get the idea. That's a nice, non-silly example of a use of algebra. Another one that I can't show you the equations for because they get really gross would be if somebody shot a missile at us. In Grossmont, we have our Patriot missile system. So they throw a missile at us. And I want this missile to hit that missile. So there's an equation of motion for this one. And I want the equation of motion of mine to meet that equation. Do you guys see that? Do you guys get the idea? So then I can set up this equation and I can equal it to this equation. Now, to be honest, it's a little more complicated than that, but it basically relies on this idea. If I knew the equation of this guy and the equation of this guy, I can set them equal to each other to force them to meet. And that would be a good thing, because then boom, up here instead of boom, down here. You guys kind of with me?
Is that kind of like that problem where they say, like, if one train leaves at this time and then this one...
Exactly, yeah. And that's one of those more silly problems, right? If one train leaves Wyoming going south 50 miles an hour, another train going north, how long until they crash or whatever? Yeah. Exactly. It's exactly the same idea. Cool. I like it. Except not quite as silly, right? So let's get on the damn train and find out. Right. This one I don't want to just shoot something up there and find out. I'd rather know ahead of time, or have the computer be able to calculate very quickly. But then as a human, I got to program the damn thing with this idea. Make these equal each other so it'll blow it up. I like it. All right. So here, try this one. There's something different about this one. Just to let you know up front. If you get some weird stuff, you expect it. Yeah, 3s are my nemesis. Number 3. I like the look of some of your faces. I think you got to the point where weirdness happens. Let it happen. You're not proving that 6 equals -3 here. It's obviously not true. Let me catch up to you guys. 4x plus 6 minus 2x equals 5x minus 3x minus 3. So I get 2x plus 6 equals 2x minus 3. If I subtract 2x in an effort to get my x's together, I always have some kind soul have an x survive. They are all dead. I'm sorry. You were too late. Dead. So 6 equals -3, and you do not want to write into the Math Journal of America and say, I have proven that 6 is -3. Remember what I said. When you get to the end, when this statement is true, then the original statement is true. Is this ever true? Therefore, this is never true. So what's the answer? No solution. I like it. So please let them die if they want to die. Don't have an X. I always have somebody have an X still here somehow. No, it's dead. It's fine. Let it go away. It's an easy answer. Now, if I did all this and I got 6 equals 6, when is 6 equal 6? Only on every third Tuesday? When is 6 equal to 6? Always. So what's the answer? All real numbers. That means that I really want this to make sense. See how x goes away? So does the answer depend on x? No. It either never works or it always worked. There's no specific value of x that saves this equation's ass because x is not around at the end anymore. It doesn't depend on x. This ain't never true. This one would be all real numbers. Would be the answer there. It's two extremes, right? When the x goes away, it's going to be an extreme answer. Yes, ma'am.
What does that mean? It's an extreme number. If you plug something, if you plug anything into X, it would work? Or
Yes. So, let me see. It could be 2 times x plus 3 equals 2x plus 6. Do you see how that's more like a definition? Isn't 2x plus 3 equal to 2x plus 6 always? Does it depend on what x is? But if I started working this out, subtract 2x, I get 6 equals 6. So you pick any value of x you want. Put a 7 in there. 7 plus 3 is 10 times 2 is 20. 7 times 2 is 14 plus 6 is 20. Put a square root of 27.3 in there. It'll work. Put a, whatever number you want to put in there, it'll work. All right, I like it. So don't look at this like, well, math, screw you, math, I did everything right, and then there's still no, of course there's no answer. There are problems for which there are no answers. We live in the life. We live here in the world. We know this is true, unfortunately. How do I get out of this? There's no way out. Ah, shit. There is no solution. I don't mean to be so bleak, but that is sometimes true. If I said, I want a number that is the same as that number added to 1, I am sorry, but you should get used to disappointment, right? Is there a number that's the same as what it is if you add 1 to it? Is there a number that's the same? It stays the same if you add 1 to it. Is there any number that does that? No, every number is going to get 1 bigger. 7 is not the same as 8. Oh, shit. So if you start to solve this, 0 must be 1 in order for that equation to have a chance to be true. 0 ain't never 1. Therefore, this equation ain't never true. That's horrible. Double negative. Ain't ever true. There it is. Are you guys looking past my grammar? Are you guys with me? All right. This is beautiful. This is real life. Sometimes, if you have this is my stupid example. If you have a lemonade stand, and let me set the equation up for how much profit, and I want to make $18 billion next week at my lemonade stand, I'm pretty sure the math is going to come out to say, if 0 equals 1, sure, you can make $18 billion. It's going to come out to no freaking solution, because there's no way. Maybe. Okay. So one last thing, and then I'll let you guys out of here. Let's try a little easy example of this. We'll get worse later. Oh, yes. Sort of like Reese's peanut butter cup. You got fractions in my equation. You got equations in my fractions. The beautiful thing, you could work with the fractions if you wanted to, and you should be able to if I forced you to. But if I just say solve this, the first thing I'm going to do is kill the fractions. Damn straight. And let me show you, there's multiple ways to do this, but this is the one that's going to make the most sense for later. What's the LCD? 15. So if I can make each of these 15, I can then multiply both sides by 15, and all the bottoms will go away. All my fractions will cancel. I can only do that in an equation. That's when I'm allowed to multiply. So how do I make this 15? So then I get 3x over 15 plus 10 over 15 equals 7 over 15. So now if I multiply both sides by 15, what happens? I'm allowed to do this. I'm allowed to multiply both sides of the equation by anything I want to except 0. So 15 goes away there and there, right? Because it distributes. And the 15 goes away there. So then I'm left with 3x plus 10 equals 7. Well, that kicks a lot of ass. So the one place you're allowed to kill fractions is in an equation, because you're allowed to multiply both sides of an equation by anything except 0. So you can multiply by the number that will kill all your fractions. So then subtract 10, divide by 3, you get x is negative 1. Yay. Alright. So, this might seem like we did it quickly, but we've already kind of done this before, accidentally on my part. I wanted to get this far so that next time we can focus on a bunch of these and then word problems. So next time it's going to be what we call application problems to make it sound better. All right. Okay.
I have a question.
Yeah.
So,